thank you, Angelo, for the introduction. And actually, I first show very quickly another application of the same methodology that Runai has introduced. That is a prediction whether a certain class of material is or not topological insulator. And this was a joint project with Carlos Costa that visited the institute from Brazil in the group of Adalberto Fazio, was at Fritz Haber for 1 year, and then of course Runai was also involved. The work was mainly led by Christian Carbonio, that you will, I don't know if he's here, but in any case you will meet on Thursday, I guess. He has his own tutorial on the error bars. So these materials are honeycomb materials. From top view is this one. Lateral view, you see they are a bit buckled. And they have this A and B, so the blue and red fished out from either 4, 4, 3, 5, 2, 6 in the periodic table. And they are functionalized off plane by these C atoms that are from the 7th group. Now, some of these are topological, so some of these meaning if you make any combination of these A, B, and C that are some hundreds, some of these are even known to be topological insulator from experimental point of view. Some are just not known, or maybe some cannot really be synthesized. And the idea was to try to understand which ones were topological insulator using a kind of simplified descriptor, so that one doesn't have to do the calculation or even guide the experiment to say this one must be a topological insulator. So the machinery that Runai has explained was applied. And this is already the result. So there is this classification. You see the descriptors are quite simple. In particular here you have even the atomic number. So in this case the atomic number turned out to be important. You may know that being topological insulator is thought to mainly depend on spin-orbit coupling, and the atomic number kind of is a descriptor of the strength of the spin-orbit coupling, at least very simple, from a very simple point of view. The striking thing of this descriptor is that one axis here that already makes a clear distinction between something that is for sure topological insulator or something that may be topological insulator, doesn't depend on the functionalization. While it's the second axis that looks into the functionalization. This is totally an outcome of the application of the methodologies. It was not put in. Now, if one looks carefully on what is this HOMO level here, electron affinity of the atom B, and then looks in what means here, what is selected for the atom C, one can give physical grounds to this descriptor, why these numbers, these quantities are really, and it is related to the position of the p orbitals that makes the sigma and the pi molecular orbital in the material. Now, I will not go into detail because it would take at least 20 minutes to really make out the story in a clear way. But believe me, and we will submit the paper soon, there is a way to work out why this descriptor is there, or to justify, let's say. Of course, this is an outcome of the application of the methodology. What I find very, very interesting, and this is why novel appears now in the title, is that one can make these materials also having A and B from 5,5 and 4,6 combination, again hundreds of these, and the functionalization is in the 6th group, the C atoms. And the descriptor doesn't know this. I mean, you can plug in the numbers, and this would be these now red dots, red circles with the yellow inside. And these are totally not in the training set, and it makes a prediction on these guys here. And then we checked sampling with the DFT calculation, and indeed it confirms exactly what the descriptor predicts. So that's good. these things, of course, await some experimental verification, but yeah, that's a clean prediction that comes out of the application of this methodology. Now I go to the toolkit, so completely switching gears. So after the coffee break, you will see the first bit of the analytics toolkit, and actually let me go directly. Oh, it was too many slides after. Okay, sorry. Do not improvise. So let me first say in general what is the toolkit. So it's a software framework. That means it's a collection of libraries for querying and analyzing the data that are contained in the normal archive. Yesterday you got, with some difficulty, a little bit of access to the archive. And these are the tools to analyze them, to analyze the data that you find. The architecture of this is modular in the sense that in principle people can reuse single tools or modules in order to build their own tools. And there are different user interfaces, and today you will see basically two that are not exactly different, but visually at least they will look different. And in general, we have that the access is browser-based via notebook interface that is running on a normal servers. That has the direct implication that you don't have, for sure here, but even at home, you don't have to install anything. You just log in, go to the right URL, and you can do even your own analysis. And the idea is that we provide some simple entry to novices and something more serious for people that want to do some more deep stuff. Okay, it's there. Actually, the best way to go is to the general portal of Nomad COE, and you go to the green button, and you enter the thing. So why this browser-based notebook is interesting? Because you have an interactive web page in which you have pieces of code that can be run. And then this is, and then you can also have pieces of text and figures and whatever. So this makes for a tutorial the ideal environment. So forget about any PDF and then go here, type this. Everything is there. And okay, so this is the places where you will go to do these tutorials. We will offer two kinds of tutorials. One, if you are really interested to understand the methodology that Runai basically has introduced, actually starting from the very simple application of lasso, dating back to actually some scrap that Jan wrote to me a few years ago, and we extended it in a fully-fledged tutorial because he needed to tell me how it was working, and then I realized that this was a good way to make it for everybody, and Emre Antish was the person that really made it into a notebook. It will be a tutor next. And then we have a more graphical interface kind of thing in which I will show in a few seconds how it works, so that you get directly into the matter without having all the tedious kind of lecture. So if you go to the Nomad Analytics page, it looks like this, and then I made it a little bit more slide friendly. The next part is not exactly like this. We will go into this predicting energy difference between crystal structures thing. As I said, so there is a long list of tutorials here, and most of them will be object of next tutorials, like Angelo and Mario Bulai on Thursday will present something on subgroup discovery. Angelo will also present something on neural network that is not yet in this list, but will be soon. Cluster expansion by Santiago and others, error bars, Christian Carbonio and others, and then these two will be presented by Gabor Sani and other people from London on Friday. So, okay, you have to log in There is actually a general hub for all the materials of this repository. Georg, who sent me this link. So if you are familiar with GitHub, you just have to remember nomad hands-on and you will find it easily. I will have the same URL in my last slide, so you don't have to, it will stay a few seconds at the end. The login is very important. You've done it already yesterday. In the analytics toolkit page, there is always this button login when you want to log in, but when you want to go to any of this tutorial and you are not logged in, you are prompted to log in, so you don't have to mind. What I want to say is that yeah, so you get this thing that most of you have seen already yesterday. You log in, and please do not use guest login. In particular, one of the tutorials will have a hard time if everybody goes into the guest login, because they will be basically everybody will be doing the same session. Not everybody, but okay. There is a limited number of sessions under guest, so please do not do guest. In general, guest is really there for people that do not want to say what they are, who they are, and whatever. So in general, yes, not today, because too many people at the same time would be a problem. The other thing I want to point out is that there is a dashboard that you can access from the main page once you have logged in. And the dashboard is very nice. It gives you the general state of your account, meaning which resources you are using, your own storage, shared storage, and then there is a list of notebooks, the one that you have created, so and those that are shared among all the Nomad community. So there will be a long list here. If you go there after you have logged in, you will find easily. Now, the first of these tutorials is this graphical user interface base. It's also the very first that we made as a proof of concept. And it's basically using CISO in order to predict the relative stability between rock salt and zinc blende, but you can choose also other combination. But it predicts the stability between two different crystal structure for octet binaries, and it starts from the usual atomic features that are listed here. In any case, the interface looks like this. You will be able to choose which input features to use, of course, among those that we offer, and which operation you allow. Basically, this is the only ingredient that you give to the method. There is another few parameters but that are also in the page, but this is basically the core of the thing. Now, here is a bit blocked, so you can choose only this, but in the real life, you could use this thing with a little bit of adaptation and plug in whatever you think is important in both kind of sets, and you will. And there is some tooltip that tells you what something is if it is not immediately clear by EA, IP, and so on. You run this and you find the solution that is basically the descriptors, and you have also a viewer that will show you the result in a graphical way. So this is basically the paper quality thing. This is what we published. What you get is very, very similar in the sense that you get exactly the same thing. The points are in the same, the color scale is different, but the same axis and the same representation. The catch is that this is interactive, so you go hover on the point, you get information on each point, you click on the point, you get the structure, and you can compare the structures, distances, whatever. So it's fully interactive viewer made mainly by Angelo. And if you're not satisfied that everything is thick and click and so on, this is a notebook. You go to notebook lock, you unlock. This is totally doable by everybody that is logged in, and you will see the code that is behind, at least the front end. And you can edit it, not just clicking. Now, another thing I want to point out that you see in the Analytics Toolkit page is the forum. You can go there and give your comment, something to improve, something that you don't understand, and so on. You will see there are already 3 active forums on bug report and comments and any kind of question that you have. This one I will do very fast. So this is really meant to be a lecture on the compressed sensing, starting from Larsson and arriving to CISO, step by step. So you will have sections like this, all collapsed at the beginning, and you can do one by one. This one is really a notebook in the sense that you will see the cells with the code, and you can run one by one and see what's happening. I will skip these tips because basically I think I can stop here, because basically this is really meant to be fully tutorial. So you go step by step and you follow the instruction. In any case, the tutors will be at hand. As I said, there are 2 fully fledged tutorials. You can choose which one you want. Time is a bit limited, so I guess you don't make it to look at both today, especially if you start from this notebook here. But in any case, they will always be there. So the moment you are logged in, you can do it whenever, tonight or the next days. So I will skip all this. You will find step by step. I just stop on the final thing. Developing the full infrastructure and developing each specific tutorial require quite some work. And this is, I hope, the full team that people have contributed. So the top line is people that worked on the general infrastructure or doing the proof of concept kind of tutorials. And these are people that contributed in one way or the other, doing some tutorial. And like 80% of these you are in the room or you will meet in these days. Some have left the team already. And here you have the link that I said, in which you find the links to the 2 tutorials that you will be doing. In any case, we will repeat them in the room after the coffee talk. Funding, and thank you for your attention.